All right, this will be a video for 8th grade, page 117 and 118. The guided practice for this section was on two separate pages. So we've got it divided up here on the left and the right. For this section, we need to recognize whether things are proportional or non-proportional. So let's talk about real quick what proportional means. Proportional is a straight line, it's linear, and it goes through the origin. Okay, so all proportional relationships look like something like this. Well, that was close, almost went through the origin. There we go. So they all go through the origin. Okay, those are proportional relationships. Maybe one goes like this. They always go through the origin. They're always lines. They always have a constant that we multiply by x to get y. So for the number 1, 2, 3, 4, actually for all these, we need to decide, are these proportional? So let's see. Number 1, this is a straight line, I can see. So it is linear. And looking at our origin, it looks like our line does go through the origin. So this one, if we determine if the relationship is proportional or non-proportional, then we need to explain our reasoning. So looking at this one, this is proportional because it is linear and goes through the origin. Okay. Number two looks kind of similar. It is linear, but we do have a problem with it. It does not go through the origin. So linear is yes, but it does not go through the origin. It goes through its 6. So this looks like it would be y equals blank x plus 6, whereas this one is just y equals blank x. This one looks like it goes up 5 over 1, so 5x, up 5 over 1, up 5 over 1, because the left is going up by 5s. This one, we're going up 3 over 3, so that'd be 3 over 3, which simplifies to y equals 1x plus 6. And this 1, you never really even see this, so it'd be y equals x plus 6. We don't really need that equation, but seeing that it starts on 6, it has a different initial value than the origin. This is non-proportional. Non-proportional, comma, not through origin. That's a U there. Not through the origin. Number 3, for the similar reason, similar rationale we had up here where we had something added, it's an equation that's not in the form y equals just kx. It doesn't just have a constant, because non-proportional, that's not an n. Non-proportional would go through, let's see, at a different point, they would go maybe through up here, or maybe down here. Just as long as these aren't going through the origin. They are normally straight lines, if we're talking about them in this chapter, but it's also possible that we have a line that goes through the origin, but is not a straight line. So I'll throw that on there too. I hope that you can see that. I'll do that a little bit darker. So it's possible that they do go through the origin, but they're curved. That's also non-proportional. So there's no origin or not linear, or neither one of those is true. So number 3, we have a slope. It's a constant, but this starts at a half. So when we compare this, we have a b. So this is non-proportional because it has a y-intercept that is not the origin. because this has a y-intercept up here. Number one does have it. It's just 0. We're adding 0, so we start at 0. So that means it is the origin. The next one, though, it looks like it's plus 0. It does have a constant slope, up 1 over 10, up 1 over 10. So this one looks like, since it does just go up 1 over 10, up 1 over 10, and does go through 0, 0, this one will be proportional. And we'll use the same rationale, or let's see, proportional has a constant slope, has a constant, and we'll just put 1/10. How about b equals 0? Y-intercept equals 0. So it goes through the origin. We'll put aka the origin. Great. For 5, 6, and 7, it says this tables represent linear relationships. All right, so these are linear. Determine if each one is proportional or non-proportional. So again, we're doing the same thing. Remember, if we have a proportional relationship, we have a constant. X is always multiplied by the same thing to get y. So let's see, from 3 to 12, what do we multiply by? Well, we multiply by 4. 3 times 4 is 12. Is 9 times 4 36? Well, yes, it is. And 21 times 4, well, let's check that. 21 times 4, 1 times 4 is 4, 2 times 4 is 8. So that is also times 4. Find the quotient of y and x, which is really what we just did. Y over x, any y over x, that's 12 over 3. So I'll actually write those up here. We got 12 over 3, that equals 4. 36 over 9, that equals 4. 84 divided by 21, well, that equals 4. So the y over x in this case, what we're multiplying by every time is always 4. So this is proportional. Constant is 4. Next one. For these ones, we're going to find y over x. So let's see. Y over x, again, is what they said to do anyway, at least on this one. Y over x, we're going to do 4 over 22, which is simplified to, it looks like we can divide by 2. 4 divided by 2 is 2. 22 divided by 2 is 11. 2 11s. So let's see if these are all 2 11s. So the next one's going to be our y over x. We'll do 8 over 46. I'm going to divide by 2. I know I can probably choose a bigger number, maybe, but 2 is definitely going to work. So 8 turns into 4. 46, that's half of 4 is 2, half of 6 is 3. Oh, and actually I wasn't going to be able to divide this one by any more. This is in simplest form. These are not equal to each other, so this is not going to be proportional. This is non-proportional. I don't even need to check this one. Not constant. All right. Number 7, the values in the table represent the numbers of households that watched 3 TV shows and the ratings of the shows. The relationship is linear. Describe the relationship in other ways. So we need to again do a y over x, and I'm choosing to make y the big number. So we've got 15 million divided by 12. I'm going to grab a calculator on this one because these are crazy big numbers. I've got no problem if you use a calculator on this kind of problem. So we got 15 million divided by 12. Well, that's going to equal 125. Actually, I'll write it here in the middle. So this was, if we're going from here to here, it's times 125. Whoops. 0, 0, 0, 0. So that would be 1,000,2050, I think. 1, 2, 3, 1. Yep. All right. 15. 1, 2, 3, 4, 5, 6. Good. The next one, we're going to do 20 million divided by 16. And I get the same thing. 125,0,0,0. So that is good so far. And let's do the last one. 25 million divided by 20. Yes, got the same thing. 1,250,000. So describe the relationship in other ways. They said it's linear. This relationship is also proportional. The number, how about the rating is always, I'm gonna put a comment. I'm gonna use another word for like a synonym here, or constantly multiplied by 1,250,000 to get the number of households. All right. So what we're looking for in these, we're looking for if it's proportional, it has a constant, it's linear, and it goes through the origin. I prefer if they're in graph form, but sometimes they're not. If they're in equation form, you're just looking for something added to the end. Okay. Another kind, I showed you this curve one, and I thought we'd have an example of one on this one, but we really didn't. So a curved one would be like y equals 3x to the second power plus 1. Any linear equation we've had so far hasn't had an exponent like this. It's just been like 3x plus 1. But if we ever have an exponent, that means your line's going to be curved. Okay, so your line's going to be a curve. Like y equals x squared looks like this. It's a curve, goes through the origin, but it's a curve like this that goes up and up and up and up and up into infinity in the positives and in the negatives. Okay, y equals x to the third is this green one that I did. That was y equals x to the third power. If you ever have y equals the square root of x plus 1, that also is going to be a curve. What that one's going to look like, I'll get a blue out. That'll look something like this. It's kind of weird. It's another curve though, because square root is an exponent. It's like an inverse exponent. It's actually a fractional exponent. This is y equals x to the 1/2 plus 1. So it's another exponent. Definitely don't need to know those quite yet, but if you ever do see any that has an exponent, please note that it is different than what we've worked with, which means it's going to be non-proportional. Those are curves, so that does not work out. So hopefully that's helpful. I think your homework assignment for Friday will be only about 5 or 6 of these. So thanks. Good luck.